Cool. So, welcome to talk number 4 of this series. Um, this talk is about a theory which is not mine, but which is the theory that really kind of got me interested in physics as an adult. So I was sort of going to go through theory from someone which kind of fascinated me and made me really kind of look up and go, this is interesting. So this theory is from a guy called Dr. Grahame Blackwell. He has various qualifications and things, degree in mathematics, statistics, and computing, has a PhD in non-military control and guidance applications of computer-based artificial intelligence, whatever that means. He's a chartered engineer, qualified teacher, and he's a physics lecturer, and he worked on the development of some of the original 3G technologies, which I sort of assume is where his interest in photons and electromagnetism came from. And he has possibly the worst website that's still online since 1996. But his books are incredibly well written, really clear, and utterly fascinating. So this talk is going to go over my attempt to explain the sort of main points of his theory. Quick recap from last time. So last time I posited the idea that all matter, light, all photons, all particles of matter or force particles, everything we've ever seen or touched or detected, or electromagnetism, and that mass can be attributed to the confinement of energy. In other words, to the confinement of electromagnetism. Just to check, can people still hear me? Because my webcam's gone funny. Yes, good. So essentially, mass and energy are equivalent, and they're related via the equation E equals mc squared. So that equation in itself gives us a clue that mass and light are related, or rather mass and energy are related, and the thing that relates them is the speed of light. So once I've turned my notifications off, I will continue. So this theory says essentially that matter is literally light wrapped into 3D structures. The theory doesn't go into detail of exactly what the different structures of the different matter particles might be, so it doesn't give detail on like what the structure of an electron versus a proton or a neutron might be, but it just says that matter is electromagnetism or photons wrapped into 3D structures. So with that as the initial assumption, and kind of the only assumption, arguably not even assumption because it's based on the idea from E equals mc squared, the theory then goes on to explain the consequences of that. So the first consequence is about what happens when you put an object in motion. So if this is just a single photon going around in a circle, and I mean, I've put a lot of wiggles in here, but the theory doesn't specify whether, you know, how many sort of wavelengths there might be in any given particle. But the theory suggests something like this, that you have a photon, which is an electromagnetic wave, and that it is looped onto itself essentially with its sort of positive and negative waveforms attracting each other, causing it to remain in this structure. And so then if you then imagine this turned through 90 degrees, so that the circling is now going backwards and forwards in and out of the screen, and you then move that particle, or the particle is moved from left to right, the path of that photon now needs to both go around in a circle, but it also needs to go along to the right, and hence it must map out a spiral in space, much like a spring or a slinky or any other kind of spiral. So it is now both going around and going along. And the faster it goes, the more elongated that spiral must be. So the consequence, or the first consequence that we come to from this, is that the faster the particle travels, the more elongated that spiral becomes. And therefore, in order for the matter to maintain structure as matter, the fastest that you can make it go is the speed of light. Because if you actually took the particle all the way to the speed of light, its spiral would actually become a straight line and it would cease to have any physical structure. So this theory says that the first consequence of matter being made of light is that that puts an upper speed limit on matter, which is the speed of light. And that is something which Einstein's special relativity tells us. But this theory now gives us a reason as to why that is the case. Whereas special relativity just says nothing can travel faster than the speed of light. This theory tells us why. The speed limit is the upper speed limit for all objects. So now we come to the next consequence of matter being made of light, which is what happens to time. So for this, we're going to look at our current scientific definition of a second. A second is the duration of 9,192,631,770 periods of the radiation corresponding to the transition between the two hyperfine levels of the ground state of cesium-133. What does that mean? Well, this is a picture of a cesium atom, and our current definition of 1 second is based on a behavior or a certain type of radiation which comes out of a cesium atom. We used to define time by the sunrise and sunset. We then moved to defining it by the Earth's orbit around the sun. And then at some point in the last century, we decided we needed something more fixed than that, because the Earth's orbit around the sun is not entirely fixed. It's not entirely constant. So we moved to a different way of defining time. And that way is this. You take a cesium atom, which presumably you can find lying around somewhere, and you bombard it with photons. And you notice this cesium atom in the outer shell, at the top, it has a single electron. And for reasons which are sort of chemistry related, that single electron is free to bounce up and down and change energy levels. So if you bombard a cesium atom with enough energy, it will then cause that electron to jump between energy levels. And as it jumps back down, it gives out a photon which has a set frequency. So it doesn't matter where you find your cesium atom, it doesn't matter exactly what amount of energy you bombard it with, the photon that comes out will always have exactly the same frequency. So it has the same frequency, it has the same wavelength. And so we define time as, or we define 1 second as the amount of time that it takes for that many wavelengths of that photon to go past your eyes. That is the current scientific definition of 1 second. And the reason I'm saying this is really to say that our definition of time is defined by a behavior of matter. It's defined by the oscillations or the cycling, or in some way the movements of a piece of matter. We don't define time through any sort of concept of space-time or any kind of ethereal thing. Our measurement of time is a measurement using matter. So back to our concept of matter being made of photons looped into structures, we can now almost think of this loop as being a clock. That it's almost like a sort of circadian rhythm of the particle. The photons going around in circles, and the theory doesn't sort of give any specifics about exactly how that maps to the behavior of a cesium atom, but essentially we say that matter is these loops, and so those loops are kind of the clock, the speed of behavior of the particles. So then if we look again at what happens when we move a particle, the loops have to then form a spiral, and we can then essentially say that that spiral has two components. It has a speed of travel component going left to right, and it has an orbital speed component, which I've just drawn as a vertical arrow on the right going up and down, but essentially that's going around and round. It's just that the circle is at 90 degrees to how you're looking at it. So we have two components, have a travel component and an orbital component, and then we have the spiral, which is going a bit along and a bit around, and the balance between how much it's going along and how much it's going around is based on how fast it's going. But note that the speed of light is fixed, so the speed at which the photon travels around the spiral overall is a fixed speed. And so we can represent that using a right angle triangle. We have the hypotenuse on the left, which is the speed of light, which is fixed. And then that is essentially just a diagonal, which is going somewhat along and somewhat up. And if you work through the maths of this being a spiral in 3 dimensions, it actually turns out that the maths comes out exactly the same as if it was in 2 dimensions. The sort of orbits of the orbital speed and the spiraling of the spiral speed kind of cancel out, and the maths just turns out that you've effectively just got a right angle triangle where you have a speed of light diagonal, which goes somewhat along to do the traveling and somewhat around and round to do the orbital speed. So again, note that the speed of light is fixed. So if you were to travel faster, as in this triangle, that diagonal remains the same length. In other words, it's not actually a length that we're representing here, it's a speed that we're representing, but that speed of light remains fixed, and therefore if the speed of travel is faster, the orbital speed must be slower. If you would have a particle at rest, which is not moving at all, then the diagonal and the vertical would be exactly parallel to each other because there is no speed of travel at all. So you just get a triangle, which is just the vertical line. So that gives us a relationship between the speed of travel and the orbits of the particle. It's a right angle triangle. And if we say that the orbits of the particle are what maps out the time of the particle, then we can use our old friend from school, Pythagoras, to say that the speed of travel, sorry, speed of time, t squared, plus the speed of travel, v, velocity, is equal to c squared. T squared plus v squared equals c squared, our old friend Pythagoras. And this essentially means that as the speed of travel increases, the speed of time for that object decreases, because the speed of light c is fixed. And this maps exactly to the time dilation equation that's used in special relativity, which, if you go looking into this stuff, you'll also come across the Lorentz transformation, which is essentially the same thing. Einstein incorporated the Lorentz transformation into special relativity, and that transformation is an equation for how time dilates when you travel at high speed. So this maps exactly to the theory of special relativity, and it maps exactly to all of the experiments we've done which have tested that theory. But this gives us a reason why it happens. So again, in special relativity, Einstein just said, when things go faster, time slows down, but he never said why. And this theory now gives us a reason why that happens. And the maths of that reason happens to map exactly to special relativity. And we can also see from this same triangle and our same piece of Pythagoras that if we make a particle move faster and faster and faster so that its speed approaches the speed of light, then its orbital speed must approach zero. That triangle essentially reduces to a zero height as the speed of travel approaches the speed of light. And you could check that with Pythagoras. It's clear to see that if v is the same as c, then t must be zero. So this then brings us to the idea of time being the fourth dimension. So Einstein talked about space-time, this idea that we have three physical dimensions, up, down, left, right, forwards, and backwards, and then we have a fourth dimension of time. And he said that the faster you move through space, the slower you move through time. There's this idea that time is a thing that you move through, space-time. You can move through space, you can move through time. But this theory gives us a slightly different view of this, which is just that it doesn't matter whether your particle made of a looped photon is traveling forwards and backwards, up and down, or left and right. Whichever way it moves, it must move in a spiral in order to do that. And therefore, time will slow down in that particle, whichever way you go. So rather than time being a thing that you move through, this theory says time is in the particle or the particles, but whichever way you move, that time slows down, which gives the perception that time is at right angles to all three dimensions, even though it's not. So this theory says time is not a dimension. There is no space-time. It's just that whichever of the three physical dimensions you move through, your time in you, in your particles, slows down. In other words, it says that there is no space-time. There is space, but time is in objects. It's you that slows down. So now I'm going to come back to a slide which I showed in a previous talk, which is about special relativity and the frames of reference. So if we remember, we've got our little person here, and they are shining a torch towards a wall on the right. And if we take our wall as being static and being our sort of static frame of reference, so we as observers are in the same still frame of reference as the wall, then light comes out of the torch towards the wall at the speed of light. And the person observes that the light moves away from them at the speed of light. Everything's fine. But then if we put our person on a skateboard traveling at high speed, they still observe that light moves away from them at the speed of light. But if you add up the speed that they are moving and the speed of light, that would mean that you should get a speed of light greater than the speed of light. As far as they can see, light is moving away from them at the speed of light, but also as we see, they are moving towards the wall. You'd expect those speeds to add up, as they do with normal speeds adding up, but they don't. Light always travels at the speed of light, regardless of the frame of reference, whether you are in a static frame or a moving frame. You can always just take your frame to be static, and the speed of light will always be constant. Now, Einstein said that each frame of reference is equally valid and real. So he said that from the frame of reference of the person on the skateboard, who from our perspective is moving, from their perspective, they could say, I'm stationary and the light is traveling away from me at the speed of light, and I'm traveling towards the wall at 1,000 meters per second, or the wall's traveling towards me. And Einstein said that frame of reference is perfectly valid and it is real, that in that frame of reference, light actually moves away from the person on the skateboard at the speed of light. That is actually what happens. But that in our static frame of reference, where we observe the speed of light moving towards the wall at the speed of light, but we also observe the skateboarder moving, that therefore from our static frame of reference, the light must be moving away from the skateboarder at less than the speed of light. He said that that is also real. It is equally valid and it is real. And that the universe translates between reference frames, which I find odd because it feels like God is sat there with a calculator, like working out which reference frame you're looking at it from, making sure that it all adds up from your perspective. That's what Einstein said. But we now have a different perspective on this from this new theory. The key thing here in this new theory is that time is mapped out in the objects. So in this new theory, we have our skateboarder moving. Light is moving away from them at the speed of light towards the wall. And therefore, if the light is moving towards the wall at the speed of light, it's actually moving away from the skateboarder at less than that. That's not because the light is going slower, it's just because the skateboarder is catching up with it. The skateboarder is chasing the light. Therefore, the difference in speed between the skateboarder and the light is less than the speed of light. But the skateboarder is moving, therefore all of the particles in the skateboarder are having to spiral, and therefore time as it ticks in the skateboarder is slower. So therefore, when the skateboarder measures the speed of something, they're measuring it with a stopwatch which is running slowly, and therefore that reduced speed of light appears to be the real speed of light. And the maths of this works out. It turns out that however fast you move, your slowing of time means that light appears to still be traveling at the speed of light because your stopwatch has slowed down. So Dr. Grahame Blackwell says there aren't multiple real versions of reality that the universe translates between. There is just one version of reality, but you perceive it at different rates of time, depending on whether or not you're moving. In other words, everything is not relative. It just appears to be. It doesn't matter whether you're moving or not moving. You can't tell because time slows down for you based on how fast you're moving. So it doesn't matter who's doing the measuring. It all just appears that everything's relative. But there is a key sort of consequence of this, which is that there can be a universal static rest frame. In other words, there can be one state of rest, which is actually at rest, and everybody else is moving relative to them. It's just that nobody could work out which reference frame that is because everybody's time dilates based on how much they're moving. But we'll come to this in a future talk, this idea of there being a universal static rest frame where there is one frame of reference which is actually correctly stood still. So back to this little chestnut from a previous talk, there's this idea of the twins paradox. And according to special relativity, if one person travels at very, very high speed on a spaceship and then comes back again, they won't have aged so much because time slows down for them when they're traveling at high speed. But according to special relativity, you could say that the spaceship was still and that the Earth moved away from the spaceship and came back again. And therefore, it's the person on Earth who should be younger when they meet up again. But this new view of time, that instead of space-time, time is mapped out in matter, this says that actually the person who goes on the spaceship and back again, they do the moving, not the person on Earth. That there is a difference. There is one person who is staying still and one person who is moving, and that explains why, as has been shown by sending atomic clocks on aeroplanes, that when you send someone or something around at high speed and then bring it back again, the person or the thing that traveled around at high speed is younger when it comes back again. And that is because there is a universal static reference frame, and that it is not correct to say that the Earth moved away from the spaceship and came back again. One of them does the moving and one of them doesn't, and the twins paradox now disappears. So in summary, time dilation now has a cause. The speed limit of objects, being the speed of light, now has a cause. The universe no longer needs to get its calculator out and translate between reference frames. There is a universal static reference frame. We just can't work out what it is. And the twins paradox is no longer a paradox. So to finish, I just want to ask the question, does it matter? Like, does it matter that this theory gives us all of the same results, but for a slightly different reason? And to me, it does matter because, or I think it matters, it might not do, but I think it does, because Einstein's theory of general relativity, which is basically special relativity plus gravity, says this. It says that matter tells space-time how to curve, and that curved space-time tells matter how to move. So I admit I don't fully have my head around general relativity and its equations, but general relativity is based on special relativity. It's based on this idea of space-time. It's based on this idea of there not being a single universal reference frame. And it's based on this idea that if you stick something like the Earth into space-time, space-time curves, and then other objects fall into the dip caused by the Earth. I think that this new view of what matter is, what time is, how time is mapped out, and the fact that there is or can be a static universal rest frame, I think this tells us that general relativity, similar to special relativity, could be correct, but for the wrong reasons. And I think that if we can unpick it, that we can potentially solve problems like dark matter, i.e., why does general relativity and its theory of gravity not work at large scales? Maybe we can answer that question if we can unpick the misconceptions that are baked into general relativity. Maybe we can get a better understanding of gravity, and maybe we can do some cool shit with it. And that is the end.